Hello guys, welcome back to our eFarm Django tutorial series on this channel. My name is Peter Evans if you're new here. So today we're diving deep into the core of poultry farm management, the models that power our poultry farm, the ones that you're seeing on your screen. And as you may know, our farm success relies on the precision and data accuracy, and our Django models plays a pivotal role in ensuring just that. So let's begin with our very first model, the housing structure. This model represents the heart of our poultry housing system, and it's all about categorizing and managing the structures that shelter our feathery friends. And now onto the flock. This model is the lifeblood of our farm, and it tracks the key details of our poultry, including their source, the breed, and the current status. But the exciting news in this tutorial is that we've introduced the concept of chunking the validators, thus ensuring that the data remains pristine. Plus, I've also added the model view sets functionalities of the filtering and also the ordering capabilities. And finally, our flock history is a model that allows us to trace the evolution of our flocks over time, and it logs the changes in rearing methods and housing structures, keeping a historical records of our farm's journey. And with that, now we switch over to PyCharm editor. So over here, we have our flock model open and ready for us to explore. I won't really go into it because I had done that in the previous tutorial. If you actually have difficulties about that, just go ahead and check the previous tutorial in this very playlist. You will learn about all these fields, but I do mean they're very quite descriptive, so I know you won't have a lot of issues with understanding them. So the new enhancements about this model is about the validation checks. We have chunked them into the flock validator class in the validators.py file. So we shall be performing validations on the chicken type. We shall also be performing validations on the flock's date of hatching, as well as also the flock's housing. Where the chicken type, we shall ensure that if maybe a flock is a broiler, it's not accidentally updated to become a layer, then the date of hatching must not be in the future, as well as also the flock's housing should be in tandem with, let's say, the flock's age. So an example is a case where you actually take a flock that is, let's say, 1 week old and then put it in a housing structure that is not really favorable for that. So we shall be raising error based on the flock's housing. And so that's it for our flock model. So switching over to our housing structure. So this model is also very simple. Just the two fields, the house type and also the category, and nothing has actually changed over here, by the way. So we are only applying a single validation check, that is the validation based on the category. So that is the only thing that is actually enhanced in this our housing structure model over here. So I'll collapse the two and then now quickly go over the flock history model. So there's nothing that has actually changed over here. The fields remain to be the same as they were from the previous tutorial, that is the flock, rearing method, the current housing structure, as well as also the date that there was a change in that flock. And so with that, we're done with the models. So I'll head over to the validators.py. So in this tutorial, we have these two validators, that is the flock validator, as well as also the housing structure validator. So I'll start with this one. So the housing structure validator class has only one static method, that is the validate category, that actually is taking these two parameters, that is the category as well as also the house type. And by the way, someone might be wondering where this category and the house type is coming from. So just to take you back a little bit inside the models and then in our housing structure over here, as you can see, the validate category takes these two parameters, that is the self category, of which that is now the current instance housing category, as well as also the current instance house type. So that is basically the operational principle of these validator checks. So we shall be performing the validations based on those two, where if the house is categorized as a brooder chick house and the house type is not either a deep litter or maybe a closed shed, we shall be raising this error brood and chick houses are limited to deep litter house or closed shed structure types. And then if a house is categorized as a breeder house, then the house type must not be of pasture housing. If that's violated, then we shall be raising the breeder houses and not allowed to have the pasture housing structure type. So these two checks are very crucial, and it makes sense because let's take, for example, you have chicks that you've just placed them in a place where it's not actually secure, maybe it's damp, there's a lot of drought, all those chicks will die. And that's the reason why the housing structure type must be a deep litter, which is always enclosed or maybe just a closed shed. And then also if we are performing breeding and then we are having a housing structure type of a pasture housing, does not make any sense because this one shall encourage vices like inbreeding and stuff of that kind. So that's the reason why I'm performing the two validation checks. And then heading over to the flock validator, we also have three methods over here. That is the validate chicken type, the validate flocks housing, and also the validate the flocks date of hatching. So starting with the validate chicken, so what we're doing over here, we're just ensuring that if, let's say, a flock was of chicken type broiler, then during an update, it's not accidentally changed to, let's say, layers. So that is what we are doing over here, where we are checking if the flock has a primary key. Just like I've told you, this method shall be accepting a flock object, where we shall be checking if that flock object has a primary key. This technically means that this flock must have been saved into the database, because it's only objects that are saved into the database that have their primary key. So basically this works only during updates. And if that's the case, then we now go and retrieve the old instance flock, and then we check the chicken type against the current flock's chicken type instance. And if there's a change, we shall raise the cannot update the chicken type. And then now we move over to the validate flock housing, which accepts these parameters, that is the chicken type, the current housing structure, as well as also the age in weeks. So here's where we perform validations based on things like the age and also the housing structure. Like in this case, the first if statement over here, or maybe the first if block, is actually performed if the chicken type is a broiler, where if the chicken type is a broiler, the housing structure must be of the broiler's house. And if that's not the case, shall be raising this error. And then this second block, we are performing validation checks based on the layers, where if the layers are 0 to 8 weeks old, we must put them inside the brooder chick house because they still be very young. And then if the layers are maybe 8 to 18 weeks of age, then they must be placed under the grower's house. If that's violated, layers 8 to 18 weeks can only be assigned to the grower's house. And then if the layers are 18 to 84 weeks old, they must be put inside a layer's house. If that's violated, we shall be raising that. And if there's any other error, we shall raise this. And then now finally, if the chickens are of the multipurpose type, then they are less than or equal to 4 weeks old, they must be put inside the brooder chick house. I hope this makes sense for you. And then now finally, we have the validate flock date of hatching, where we ensure that the date of hatching is not in the future. And so that's it for our validators for today's tutorial. So I'll quickly head over to the signals. So over here, I've introduced a new signal, that is the create flock history. So this create flock history signal is just a method that is a preset signal that shall be ensuring that our flock history objects are created correctly, where just before the flock object is saved, the preset signal is always being emitted. And then now what we shall do is that we go and check if the instance has a primary key. So the instance that we're talking over here in this method is the flocks instance. So just like I've told you in the validators.py a couple of seconds ago, if the instance has a primary key, that is what we are doing here. If the instance is not none, meaning that there is something, or maybe there's a primary key, then we shall retrieve the old instance, that is the flock object itself, and then now check if its current housing structure has actually changed, where the instance current housing structure, that is the very flock's housing structure that is to be saved, is not the same as the old instance, the one that is retrieved. Then we shall create a new flock history object, or maybe if the rearing method changes, so we shall be creating new flock history objects based on these two conditions, if this field changes, or maybe if this field changes. And so that's it for our signal. So I'll quickly just now head over to the serializers. So over here in our serializers, we have the housing structure serializer. Nothing has actually changed. I've left it simple this way because there's no any special operations that is supposed to be performed. And then for our flock serializer over here, we have this source and the breed field. From the previous tutorial, it's clear that we've enhanced these two fields over here, that is the source and also the breed. So this one shall technically introduce the nested serializer problem, but we shall be handling that in the create method of this flock serializer, where I've actually overridden it to ensure that if we are to perform the creation of a flock with maybe like new source at the very same time, so just by a single request we can create a new flock with a new source at the same time, or maybe a new flock with a new breed at the same time. So that's basically what we're performing over here, where we pop the source and as well as also the breed. And then now we perform the get or create, where if the source is actually there, then it shall return that source, or maybe if it's not there, then we shall create that source. And then after creating it, and then now that is what we shall be using to create the new flock object that is being created at that particular point in time. And then moving down to our update method over here, where we've also overridden it, we ensure that these fields are actually not updated, where we shall be excluding them during the update operation. So it's only a single field that we shall allow the updates. So the field is here, that is the current rearing method. So the reason why I've done so is that there is no way that all these other fields are actually to be updated, like let's say source, the breed, or maybe the date of hatching, the chicken type. So chances have it that it's very minimal chances that this field shall be updated. Even the current housing structure, I know you might be wondering, but hold on, in the next tutorial we shall be tackling the flock movement and you shall understand how this one really works. So what's happening over there is that we shall be performing just the update on a single field, that is the current rearing method. So that's it for the flock serializer over here. So the flock history serializer over here, it's quite simple, and because everything is being performed automatically, just like I told you, the signal itself over here, just a pre-save signal ensures that we actually save a new flock history. So this one technically means that there's no any manual intervention over here, and that's why they're all read-only fields. And so with that, we quickly head over to the permissions.py. So in the permissions.py, we've added new permissions over here. First up, we start with the can act on housing structure. So this is a permission that shall be applied on the housing structure view set that shall ensure that it's only the farm owner as well as also the farm manager that is allowed to perform any action on these housing structure objects in our database. So if that's actually violated, then we shall be actually returning the only farm owners and managers have the permissions to perform these actions, where this one shall be thrown if that person does not have sufficient rights to perform that action. Or maybe if the person is not logged in, then we shall raise the authentication credentials were not provided. So then we have the can add flock, where the can add flock we restrict to only the farm owners as well as also the farm managers. The same thing applies to the can update flock, the can delete flock, but for the can view flock, we allow the farm staff, all of them, to actually be able to view the flock objects or maybe the flock records in our database. So finally, for the permissions, we head over to the last permission, that is the can act on flock history. So this one is also restricted to only the farm management, that is the farm owner, as well as also the farm manager. So the same principle just applies. If the person does not have the sufficient rights, then we shall raise the permission denied of the message. Only farm owners and the farm managers have the permissions to perform this action. Or maybe if that person is not actually authenticated, then we shall raise the authentication credentials were not provided. And that's it for our permissions. So let's switch over to the views. Well, over here we have the housing structure view set, where we are also activating the filtering and the ordering functionalities, just like we did from the previous tutorial. So we shall be able to order based on the housing type and also the category. And then also we are applying the permission classes, that is the can act on housing structure. Just like I told you, it's only the farm owners as well as also the farm managers that shall perform any action on the housing structure objects in our database. And then also now we override the list method over here to ensure that if the request is actually associated with any query parameters, that is, let's say, filtering or maybe ordering, then we are able to actually return the records correctly. Where if the query set does not exist, meaning that there is no any stuff that is actually returned from the database based on if the query parameters that are associated with the request does not actually filter anything from the database, then we shall be returning the no housing structures found, matching the provided filters of the status 44 not found. Or maybe if we do not just have the housing structure objects in our database, then we shall be returning no housing structure found in our farm yet of the 200 OK. And maybe if there was something, we shall be serializing that and then returning that with the status 200 OK. And then now our flock view set just similarly operates on the same principle. We shall be able to perform filtering and also ordering. So we shall be ordering from the most latest, that is the date established, as well as also the source of the flock. And then now we apply the permissions by overriding the get permissions, ensuring that it's only the farm owner as well as also the farm manager who can add flocks. We also ensure that if it's supposed to be the updates, then it's only the farm owner and also the farm manager who can do that. And if it's about deletion of a flock object, then same thing applies over here, but for the viewing, the whole farm staff shall be able to view that. And then now what's happening over here is we override the partial update as well as also the update. So this one is basically the patch request, and then this one is also the put request. Since in our serializers over here, we actually ensured that there are some fields that are actually popped during any update. So let me just show you, like you can see the source, the breed, the date established, as well as also the is present over here. So similar stuff now applies over here, where during the put request, we ensure that that does not happen because the put request requires that all those fields are actually populated. But for the patch request, it's only the single field that shall be the current rearing method that shall only be allowed to be updated. So I hope you understand that, but if there's confusion, don't hesitate to ask that out. So that is what is happening over here. And then also for the list method, we also just apply the similar stuff just as we've done for the housing structure over there. And then now finally we have the flock history view set. Similar thing just applies, so there's no need of even explaining this. We just apply all this stuff in a similar manner. And so that's it for the views. And now we head over to the tests. So in our test folder over here inside the poultry, then over here I have added 3 new test cases. That is for the test housing structure view set. Let me just scroll up. Yeah, you can see it. Then we also have the test flock view set as well as also the test flock history view set. So I'll just touch on just a single test and then I just run the others. But if you have issues with understanding how these tests are actually configured, please don't hesitate to ask that out. So as you can see in this test housing structure view set over here, we're supplying the authenticated and the authorized users as well as also the housing structure dictionary data. And then now we have the tokens for the regular user, the farm owner, the farm manager, the assistant farm manager, the team leader, as well as also the farm worker tokens. And then now, this is the only test that I actually go through. So we're testing the creation of the housing structure as a farm owner, where we send a post request to this URL over here. Of course, this URL will resolve to, basically that's what the reverse function does, poultry/housing structure/add, or maybe something of that sort. And then the request payload, which is the data, will be the housing structure data. So the housing structure data over here inside the conf.py over here, yeah, you can see this setup housing structure data function actually yields the dictionary of the housing structure key, housing structure data key, and the housing structure, which is whatever we have over here. So back to our views. So that's basically what's happening over here. And then the authorization token, since I've said that the housing structure shall only allow actions from the farm owner as well as also the farm manager. So if we send that, we verify that the response status code is to a one created, and then we also verify that the housing structure actually exists from our database. And so that's it for the brief explanation of the test. So if you want to know more, just quickly go over through all this. Only if you have issues, then don't hesitate to contact. So I'll head over to run the test. So by test, and then now we have 370 tests as per now. So this is collective for the dairy as well as also for the poultry, all that we've done up to now. So since these tests will take quite some time, I'll just quickly fast forward this. Alright, so in about 7 minutes, all the 370 tests have actually passed, marking the end of this tutorial. And so that's it. See you in the next one, and bye bye.